Assalamualaikum warahmatullahi wabarakatuh. This is the last subtopic for the transformer, which is we will cover the auto transformer and also the three-phase transformer. So what is auto transformer? It is a transformer whose the primary and the secondary coil are in a single winding. Okay, meaning that there is no isolation between the primary and also the secondary. So the operation of this auto transformer are the same with the two winding transformer, but there is no what you call electrical isolation, meaning that there is a physical connection from primary to the secondary. Okay, and it has a what you call the sliding connection to allow the variable output voltage. Okay, okay. So the advantage of using this auto transformer is that we can have a tap between the primary and secondary sides, which can be adjusted to provide either step up or step down capabilities. And another advantage is that this auto transformer is able to transfer larger apparent power than the two winding transformer, and it has a smaller and lighter than equivalent two winding transformer. The disadvantages of this auto transformer is that it lacks electrical isolation, okay, because they have a physical connection between primary and secondary winding. So this is the relationship between the voltage and the number of turn. Okay, so this is for the step down auto transformer. And this one is a equation for step up auto transformer. And the example 4.7, okay, example 4.7, an auto transformer with a 40% tap is supplied by a 400 volt 60 hertz source and is used for step down operation. A 5 kVA load operating at unity power factor is connected to the secondary terminal. So find the secondary voltage, the secondary current, and also the primary current. So we have the solution here. So since it actually has a tap of 40%, so you can actually arrange the equation for the step down auto transformer as follows. And then from this equation, you can get your secondary voltage is equivalent to 160 volt. Okay, and this is for the what they call the secondary current. Okay, so we have the apparent power 5,000, so over the voltage secondary, which is 160 volts. So the current that flows inside the secondary current is 31.25. And to obtain the primary current, so we know that the apparent power at secondary and the primary side is equals. So from that we have V1 of which is a 400 volt. So we can calculate the primary current equivalent to 12.5 ampere. Okay, so we have finished with the auto transformer. So this is a three-phase transformer. So the three-phase transformer can be built by either the interconnection of 3 single-phase transformer and also using an iron core with 3 limbs. And the usual connection of the three-phase transformer are Y, meaning that this is the primary and then this is the secondary, so Y connection. Okay, but this connection is seldom or not very preferred to be used because of easy unbalanced. So because this transformer is very easy to be unbalanced, and we have what called the third harmonics problem. And the second connection is the what we call Y delta connection, and this is used normally for step down transformer. Okay, and we have what we call delta delta transformer. Okay, so mostly it is used in a medium voltage, which is around 15 kV. And for this delta delta connection, there is a special features that where one of the transformer can be removed. Okay, maybe due to faulty or maybe to the maintenance reason. And the last one is the delta Y connection. So this is the step up transformer and mostly used in a generation station. And for most cases, which is involve the Y connection, most cases is actually has a neutral point that is grounded. Okay, so this is show a three-phase transformer that use three limbs. So this is the primary side, and the blue color is the winding, the secondary side. And as you can see here, the primary is connected in Y, and the neutral point is actually grounded, and the secondary is connected in delta connection. And this is actually the relationship between the voltage line, voltage phase, I line, and also I phase. So for example, this is for Y to delta connection. Okay, so we have the V line here. So to transfer for the secondary, what we need to do is actually to have the V phase, and the voltage across the secondary is actually equals to the V phase at the primary. Okay, and then for the current, so I line is I phase for the primary. Okay, so for the secondary, I phase is also equal to the primary, but with a multiplication of A, which is, you know, A is actually N1 over N2. Okay, and to get the line current, okay, so you need to multiply with square root 3. And this one is for the step up transformer, where this is a delta to a delta Y connection. So at the primary side, the V phase is equal to V line here. So at the secondary side, the V phase is equivalent to this one, but with a over A here. Okay. So for the analysis of the transformer, so it is better to have to use a single phase equivalent circuit instead of three phase. Okay, so the validity of this condition, meaning that to use this method, the transformer must have a balanced source and also balanced load. Okay, and as you can see here, this is Y delta connection. So what we need to do is actually to transform this delta into its equivalent Y connection. So the transformation can be used this one. Okay, so if you have the delta like this, so if you transform into a Y connection, so all the impedance will be divided by 3. Okay, and also for the voltage, so the voltage across each element here is also need to be divided by 3. So this is the equivalent of Y connection after the transformation. Okay, and if this has been done, then you can actually build your single phase equivalent circuit as shown like this. And for delta connection, so this has a several we have a special features for this delta connection, where only this delta connection where we can actually pull out one transformer. Okay, maybe due to maintenance, or maybe the transformer are in faulty conditions. Say, okay, so one phase can be removed, okay, but the power, okay, the power that when this is removed, meaning that only two transformer will actually functioning, and actually the total power of this what you call VV, because this is not delta anymore, so this one, this is open, so the shape is like a V, so that's why we call VV transformer, is actually dropped to 58% from its full capacity as a delta transformer. So actually this one shows how it is we can find what is the maximum capacity here. Okay, this is can be done by using two wattmeter method. So this is the wattmeter that may be connected here, and then another second wattmeter connected here. So this is the reading equation for PAB, and then this is the reading equation for PBC. Okay, and finally we will obtain this equation, and this is the full power capacity when it is in a delta connection, which is 3VI, and we computed it. So actually it is actually 58% only from the total power when the transformer is in a full delta connection. So this is why and when the delta, what I call open delta transformer can be actually execute, is when the current of the load right now is too small to warrant a full three-phase transformer system. So meaning that we can open one transformer, and then maybe the second reason is that maybe the one transformer is disabled for maintenance purpose, and maybe the transformer is installed, but with an anticipation that the future load will increase and can warrant the use of full three-phase transformer. Okay, so this is actually the overall construction of the three-phase transformer. Actually, it is very similar to the single phase, but with some what I call unique features, because usually the three-phase transformer are used in the high power applications. Okay, and for example, the winding is made of copper or aluminum conductor, and then it's insulated with paper or synthetic insulating materials such as Kevlar or Maillard. And it can be actually arranged like this. Okay, so this is for small transformer. And this is for the three-phase transformer. So as you can see, this is use a three limbs transformer core here. So each limb is actually a phase A, phase B, and phase C. And in terms of the what we call cooling, okay, cooling method. So actually we have three types of cooling method. The first one is we cool the transformer by using oil base. Okay. So the end of the winding are connected to the bushing. So this is actually the bushing here. So this is what called the bushing. So we have phase A, phase B, phase C. Okay, primary, secondary, and also primary, secondary. So that is actually bushing. Okay, so the oil is circulated by pump and forced through the radiators. So we cool down the transformer, because transformer will become maybe become hot. Okay, when operation. So we need a coolant to cool down the temperature. Okay, so we are using oil here. The second is actually we can use what we call a cooling fan. Okay, and the same with the oil base. So actually the end of the transformer is connected to the bushing. So this is actually the upper one is what called the bushing. Okay. And the last one is the what we call air cool. meaning that it is open. Okay, the transformer is open, and it's actually the cool is actually done by the environment. So this is what we call a dry type transformer, and this is usually used at the medium and low voltage. Okay, I think that's all for the transformer. Thank you very much. So we have actually complete this topic too. So Alhamdulillah, maybe we will go for the next topic, which is the power generation, transmission and distribution. So thank you very much for your attention.